The first image from Mars that made Earth hesitate was never meant to exist. It was a simple transmission, a narrow-band feed captured by the Deep Space Network, sent across more than 200 million miles. The frame was clean, the calibration perfect, yet what returned was not a photograph of dust and shadow, but a geometry that seemed to know it was being seen. The Jet Propulsion Laboratory confirmed the signal integrity within minutes. No packet loss, no solar interference. The data was flawless, and that was the problem. Across a landscape thought to be random, there appeared a lattice long ridges aligned with impossible precision. Each line mirrored the angle of sunlight at that moment. Each intersection formed at ratios that matched harmonic resonance in Earth's own magnetic field. The images was both familiar and foreign, mechanical yet silent. At first, analysts blamed the imaging sensor, but the same pattern appeared when the feed was reprocessed from backup relays in Canberra and Madrid. 3 different paths, one identical result. When they adjusted the brightness curve, the structure vanished. When they restored the original dynamic range, it returned again. It was as if the surface of Mars only existed when viewed honestly. The discovery divided the teams. Was it evidence of unknown geology, or an illusion born of precision too perfect for comfort? The sharper the image became, the less sense it made. The first image from Mars did not reveal the planet, it revealed the limits of sight. Precision rose, certainty fell. When the first patterns appeared in the Mars reconnaissance feed, the engineers turned to calibration logs. The high-resolution imaging science experiment, known as HiRISE, used a mirror assembly ground to within 1/5000th of an inch. Its sensor array was cooled to 180 degrees Fahrenheit below zero. Every photon that touched its surface carried the echo of sunlight filtered through carbon dioxide, frost and iron dust. The system was designed for precision, not imagination. Data flowed from the orbiter through the relay at Cassini, then through Voyager's network echo before touching the antenna at Goldstone. From there, the signal crossed to Canberra and Madrid, creating a planetary triangle of reception. Each node verified bit-level integrity. If one packet had shifted, the checksum would have failed. It did not. The geometry persisted. At JPL, technicians tried to reproduce the anomaly by simulating camera drift. They rotated mirrors, introduced static noise, and recalculated lens diffraction. No combination of physical distortion reproduced the symmetry. What appeared on the Martian surface followed the logic of design, not erosion. Parallel ridges ran for miles, intersecting at ratios close to the golden mean. Even after contrast correction, the structure refused to dissolve into randomness. Geologists proposed a theory of polygonal terrain caused by permafrost contraction, but that would require water ice far below the equator, where temperature never dropped low enough to sustain it. Another group invoked magnetic alignment iron-rich dust forming along local field lines. Yet the magnetometer on Perseverance recorded flux too weak by 2 orders of magnitude. The models failed faster than they formed. Then a smaller discovery deepened the paradox. Thermal emission from the same region pulsed with the orbital period of Earth's rotation, a geological formation responding to another planet's day-night rhythm. It made no sense, but the data was repeatable. For every attempt to simplify the image, another layer of complexity emerged. The question shifted from what the image showed to what the instruments were capable of seeing. At what point does measurement create the thing it observes? And if the image is a mirror for precision itself, what happens when clarity exceeds understanding? Awareness rose, certainty fractured. The debate began quietly in the telemetry lab. Engineers insisted that the geometry was a statistical mirage, a side effect of compression and digital reconstruction. Every image is an act of interpretation, they said. Noise can sing if the algorithm listens hard enough, but the checksum logs remained flawless, no data corruption, no algorithmic interpolation, no software artifacts. The structure was not invented by the machine. Planetary scientists proposed a simpler cause frost heave across a mineral crust, carbon dioxide sublimating in cycles, shaping polygons through expansion and collapse. Yet those patterns exist only at high latitudes, and the image came from near the equator, where the ground never cools enough. The numbers refused their hypothesis. A physicist from the University of Arizona tried to test the limits of coincidence. He generated 1,000 random landscapes with equal spectral walled noise. Not one formed symmetry within a tolerance of 1 degree. The odds were lower than quantum background fluctuation, a pattern so improbable that its existence mocked probability itself. At a closed NASA review, someone suggested that the camera might be reflecting a hidden interference from Earth's own transmission bands, but the signal path was one way, and the delay between packets exceeded 8 minutes. No feedback could traverse that gap. Still, the geometry echoed solar alignment back toward Earth, as if responding to the observer. Philosophers of science called it observer coupling, the idea that measurement entangles perception and phenomenon. The instruments do not merely record reality, they participate in it. If that were true, then the geometry was not on Mars alone, but within the logic of the system that revealed it. The argument split into two camps. One believed the pattern a physical formation awaiting explanation, the other claimed it was a mirror held up to cognition itself. Both pointed to data, neither could falsify the other. In the archives, an engineer compared the anomaly to the first data from Voyager 2 at Neptune, the same oscillation in the transmission noise floor, repeating at harmonic intervals, a resonance, not of hardware, but of observation. The sharper the focus, the deeper the uncertainty. The image became an equation without a known variable, a symbol that meant nothing and everything at once. Numbers aligned, belief drifted. Months after the argument cooled, a second mission turned its lens toward the same Martian plane. The Mars Reconnaissance Observer passed overhead at a slightly different solar angle. Again, the pattern appeared lines, arcs, and nested hexagons, but now their alignment shifted in synchrony with the Sun's position, as though the terrain had learned to follow light. At first, the team assumed a calibration echo, a ghost of the first survey encoded in the imaging algorithm, yet the new system had been rebuilt from the ground up, every checksum re-verified, every compression protocol rewritten. No data could have migrated across missions. Still, when the geometry returned, the spacing between ridges matched the wavelength of red sunlight scattered through the planet's thin atmosphere. Then the Parker Solar Probe detected a minute fluctuation in the solar wind 1 pulse every 24 hours and 37 minutes, the length of a Martian day. The signal propagated through the heliosphere and brushed Earth's magnetosphere 30 hours later. For 2 days, the Schumann resonance frequency on Earth rose by a fraction of a hertz, then fell back. 2 planets linked by a pattern no theory predicted. Data analysts built a cross-correlation model. They expected random noise. Instead, they found phase lock and identical timing error across both streams. The same tiny offset appeared in the Voyager archives from decades earlier. Light, magnetism, and perception seemed to share a hidden rhythm, a conversation conducted in microseconds. Skeptics warned against cosmic coincidence. Random alignments happen in vast datasets, but when a third instrument, Hubble's infrared array, captured Mars through Earth's atmospheric window, its thermal image pulsed in step with the solar wind reading. 3 devices, 3 domains of physics, 1 shared beat. The paradox expanded beyond geology. If observation could alter magnetism, and magnetism echoed back into observation, then data was not passive, it was interactive, alive within its own precision. At the European Space Agency, a theorist offered a new term, resonant awareness. He proposed that systems of measurement can fall into temporary coherence, sharing information through the act of recording. The hypothesis was untestable, but its mathematics matched what the sensors saw. Earth was not blind because it could not see, or it was blind because it saw too well. Perception had reached a resolution where the difference between signal and self disappeared. Truth neared, assurance receded. For centuries, observation was humanity's purest form of faith. To measure was to believe. Every image, every dataset, every pulse of information arriving from deep space carried the same quiet assumption that truth existed independent of the eye that saw it. The first images from Mars fractured that faith. Inside the control room at the Jet Propulsion Laboratory, screens glowed with perfect symmetry. The pattern no longer belonged to the planet, it belonged to the act of perception itself. Engineers who once trusted numbers began to hesitate before running new calibrations. The data was clean, but their confidence was not. One researcher described the feeling as the silence between 2 mirrors. When every reflection becomes identical, perspective disappears. The clearer the image, the more it folds back upon the mind that observes it. The debate turned philosophical. Was the universe built upon code that humans could decode, or was measurement merely a language written by those who seek it? If the geometry on Mars was not random, perhaps neither was the human mind that recognized it. 2 systems, one of rock and one of reason, resonating across space. In a small paper published months later, an astronomer suggested that the anomaly might be the first measurable example of cognitive interference, a point where an observer's expectations create interference patterns within data reconstruction itself. Not mysticism, but mathematics of attention. The more one looks for coherence, the more the noise aligns to satisfy the search, a feedback loop between inquiry and illusion. The reflection spread beyond laboratories. To some, it was proof that humanity had reached the event horizon of comprehension. To others, it was simply another reminder that the map can never contain the territory. But between both camps, a quiet understanding emerged that every instrument is also a mirror, and every question carries its own distortion. Understanding rose, wonder fell. In the end, the image remained unchanged. A field of ridges, intersecting lines, shadows too precise to be random. It never proved life. It never disproved it. It only measured the boundary between knowing and seeing. NASA archived the data without conclusion. No public announcement, no declaration of error, just a note in the catalogue. Anomaly retained unclassified geomorphology. On the official map of Mars, the coordinates exist as a grey square, neither confirmed nor dismissed. Every few years, a probe passes overhead and captures the same geometry again, always identical, always silent. Scientists have stopped arguing about what it is. The debate has shifted toward what it means. Perhaps the pattern was never a message from another world, but an artifact of our imperfection, a mirror polished until it reflected the eye that built it. The instruments reached their limit, and within that limit, awareness began. Precision rose, certainty fell. The first images from Mars did not turn Earth blind. They taught it how to see.